Welcome back to another episode of Codat. I'm here to talk about something very interesting. How exactly does AI work? So artificial intelligence is all around us, powering everything from your social media feed to self-driving cars, but the heart of AI is something called neural network. And this is the powerful tool that, basically the brain behind AI. How it works is it learns from data. It gets smarter over time and helps machines make decisions almost the way humans do, basically. But how exactly do neural networks work? How do they learn? So in this episode, I'll break down the fascinating process of deep learning. First things first, what exactly is a neural network? In simple terms, it's a network of artificial neurons that closely mimics how the human brain works. Each neuron is a tiny computing unit that processes information just like the brain. These neurons are connected in layers. So we have what we call an input layer and what we call the hidden layer, and then we have the output layer. So these three layers compute what we call neural network. So the input layer takes in data. This could be anything from an image to a text or even audio, video, whatever. The hidden layers process this data, extracting important features, while the output layer gives us the results or the prediction of what we had in the input layer, basically. Now let's get into the magic learning. Neural networks learn through a process called training, which involves feeding them large amounts of data. They analyze the patterns in this data, adjusting the internal settings known as weight and bias. But how do they know what to adjust? Here comes in what we call forward pass and backward propagation. In the forward pass, data moves through the network layer by layer, producing an output. At first, the output is probably wrong, but that's just where the learning continues until it knows what exactly is right. To improve its prediction, the network uses something called a loss function. And there are various types of loss function. There's sigmoid, there's different types of loss function. Maybe in another episode I'll get into the different types of loss function. Now this measures how far off the network's prediction is from the actual answer. The higher the error, the more the adjustments the network needs to make. Now let's talk about what is backward propagation. So here is where backpropagation comes in. So think of it like trial and error. The network works backwards, adjusting the weights and biases in each layer to minimize the error. This process happens over and over and over with each cycle, which is called an epoch. Now, over time, the network gets better at predicting the right answer. So that's between forward and backward propagation. So what happens if the neuron should fire or not? This is where activation functions come into play. They control how much signal from one neuron passes to the next. Neural networks have endless applications, from recognizing objects and images to translating languages to even beating humans at games like chess. So what is truly amazing is that these systems get better as they get exposed to more data. So the more data that they have, the better that they get, basically. And the more they can handle complex tasks. So it all comes down to data. Which is why AI is involved so much now, because there is so much data. In a nutshell, neural networks learn by adjusting themselves based on the data they are fed. They use technologies like forward pass, backward propagation, activation functions to make sense of the world. Whether it's finding patterns in images or driving autonomous cars, neural networks are truly the brains behind modern AI today. If you found this deep dive into neural networks helpful, don't forget to give me a video thumbs up, to subscribe, and also I'm going to probably dive deeper into more of this, and let me know what you think about these kind of topics. Thank you so much, guys, and have a good one. Bye bye.